class. So this is chapter 2's video. It's physical systems. So it's matter, energy, and geology. Kind of a little overview of the other major sciences that are part of environmental science. So the chapter opens up with the case study on the Tohoku earthquake. It happened in Japan, 2011. And basically what happened was there was a huge earthquake that occurred through a convergent plate boundary. So the one plate went underneath the other, and that caused a tsunami. All right, the problem with the tsunami and its crazy waves is eventually the nuclear power plant was located along the coast and got completely flooded, which then led to a complete meltdown. I do have a great documentary of this, and it's pretty cool. It's all real life footage. So if you're interested in watching it, let me know. This topic has shown up on AP tests in the past, so just make sure you have an idea of all the different steps of what happened with this one. Okay, and there's an example of like tsunami waves coming in and crashing in. It was pretty cool. So again, have an awesome video. All right, chemistry. So before we get into chemistry, you should know about these top threes. Okay, you need to know the top 3 elements of Earth's crust, which is oxygen, silicon, and aluminum, and the top 3 gases in the atmosphere. You do need to know these percents. Okay, these will show up. So you need to know that nitrogen is 78%, oxygen is 21%, and all other gases add up to the other 1%. Okay, if you look here more specifically, if you want to know an order of all the other gases, argon is number 3, and then all others. Okay, so these are important. You do need to know those. All right, from chemistry, review what an isotope is, radioisotopes, half-life, and radioactive. Half-life likes to appear sometimes in the FRQ questions. And they also like to discuss about radioactive elements and its reactions. So make sure that you understand that process and what it means to be an isotope, how half-life works, and you're radioactive. So that's the big thing that you need to make sure that you know. All right, skip this. Okay, you need to know bonds, okay? So here's your covalent bonds, water. It's really important to understand that between the oxygen and the hydrogen, it is a covalent bond. So just make sure you understand that. Again, one molecule of water, and then the different atoms that make it up. There's a hydrogen bond, and then your covalent bond. All right? So just make sure that you understand that. All right, next part, water properties. So these are the 4 properties of water: that it bonds well with ions in the solutions and dissolves. Ice is less dense than a liquid. This is why ice floats. And the cool thing is ice prevents ponds from completely freezing through. And that's because the ice goes from shore to shore and all surfaces so that the water underneath is able to last. Okay, cohesion, and then heat weakens the hydrogen bonds. Next thing, pH scale. Need to know it. We will be discussing pH a lot when we come into pollution, all right, and water quality and air quality. So make sure you know which one's an acid, which is a base, and examples. So normal rainwater is not neutral. It's actually a little more acidic. Then you can see acid rain and so forth. So those are important. Just make sure that you know that it's 10 times the hydrogen ion. All right. So instead of the concentration being 1 from a 9 to an 8, it's actually 10 times. So just make sure that you know that difference. You could get the math question and asked about that. Okay. All right. Next one, hydrocarbons. All right, make sure you know what a hydrocarbon is. It's made only of a hydrogen and carbon. That's why it's called a hydrogen carbon. Okay, examples of hydrocarbons are crude oil, petroleum products, which include plastic, natural gas, and coal. Okay, a lot of the petroleum products are made out of crude oil, but they're all considered hydrocarbons. Okay. Now carbon, we're going to watch some videos about carbon in class, but pretty much because of the discovery of fossil fuels, it has helped us create wealth and the modern lifestyle that we know today, mostly because of the heating. Okay, and when we heat fossil fuels, it breaks the carbon bond, and that's how energy is released. The broken carbon, okay, in electricity connects with two more oxygens, and that's how we create CO2, or carbon dioxide. This is our nemesis. It has to do with global warming and other things. So this is a greenhouse gas. So we'll be talking more about CO2 in this class. So anyway, some of the CO2 gets dissolved in the ocean, and that's how we get carbonic acid. Some of it is taken in by trees, and they make it into tree issues. Thank your photosynthesis. And this making tree issues is called sequestration. But it stays mostly in the atmosphere, and that traps heat, which makes us have a warmer planet. So if we didn't have any CO2 and greenhouse gases, we'd be freezing and not living. All right. Physics. Make sure you know the first and second laws of thermodynamics and have some examples. So I gave you some examples of both potential energy and kinetic energy. And even down here, this drawing, this figure and caption is pretty important. Okay. So make sure you're able to explain it, and also what happens during kinetic energy. Okay, the big thing is, as you can see here, as it burns, both water and CO2 are released. So you should know that one. Other thing is entropy, and then energy conversion efficiency. All right. So remember, you need to know all those guys. Okay. Equations that you've been learning your whole life. You need to know photosynthesis and cellular respiration. A lot of times these equations will pop up on exams. So make sure that you know that water, okay, photosynthesis has a net consumption of water. So we take water in at 12, but we only have 6 left. So we actually consume water in this process. So make sure that you are aware of that. Cellular respiration. Also, we consume water, and then it is sugar and oxygen. Okay. A lot of time these questions pop up as multiple choice questions on the AP exam. Okay. All right. Energy other than from the sun. Okay. There's gravitational pull of the moon, which is called tidal energy. You will talk a little bit about that. Okay. And then also there's radiation inside of the Earth, okay, which powers plate tectonics, volcanoes, geothermal, and hydrothermal vents. And just to make sure you know that in hydrothermal vents, chemosynthesis happens. So here's the equation. All right. These are the ones who don't use sunlight. So remember that. They use sulfur. Okay, see, hydrogen sulfide is in the equation. So that's just a unique thing. Make sure that you know that equation as well. Some cool things. The Yellowstone National Park is actually known for geothermal energy, and all of your hydrothermal vents can be found in the deep ocean, usually at divergent boundaries. All right, this figure, this you should know, and roughly which is the thickest and thinnest layers and what they're comprised of. So just also go with our notes. We have oceanic and continental crust. Then you have the uppermost mantle. You have the asthenosphere, which is the plastic-like layer. And then you have the lower mantle. Then you have the outer core, which is liquid-like. And then you have the inner core. So this is a really important figure because they might discuss the layers. Okay. All right, next page is a lot of important stuff. First thing, you need to know all these different plate boundaries and what's going on with them, okay? First is your divergent boundary, okay? The Mid-Atlantic Ridge is a famous one. As you can see here, magma rises up This is when your crust is created. Here's your ridge. The Mid-Atlantic Ridge is the one that's within the Atlantic Ocean. And you can create volcanoes here during a divergent plate boundary. Okay. The next one is your strike slip, or another name is your transform. Again, this is when they slide past each other. So you can get a fault line that's there. So this is exactly what the San Andreas Fault is. So again, you're just removing or relocating the crust. You're not destroying or creating. All right, subduction. Two types of convergence, okay? Here's your subduction, so the oceanic plate, because that's denser, it goes underneath, hits the magma, creates a volcano, and you also get a trench, okay? So those are two different landforms that convergence can create. Other big thing is, if you have two continental plates, as you can see, one is subducted, but not as deep, so all you get is mountains. So it's a collision that creates mountains, okay? So here's my little notes, cheat sheet. So oceanic crust is denser, so it'll always go underneath the continental. Subduction always happens, and you always get a trench. Two continental crusts have the same density, so they'll always push each other up and create a mountain. All right, image at the top. So Pangaea, all right, this is way back when what we believe Earth looked like at some point. So I want you to take notice of where India is here. All right, over time, things have changed, and now we see where India is here. So now it's part of the Eurasia plate. Okay, India plate actually is on the India-Australian plate, so this is one big plate. So this is where the Himalaya Mountains is. So prior to, back when it was Pangaea, the Himalaya Mountains didn't exist. All right, it's between Asia and India, and it's forms from a convergent plate boundaries. And the Himalaya Mountains are continuing to grow. So as you can see here with the convergent boundary, it's continuing to grow. If you look here, here's the Mid-Atlantic Ridge that we were talking about before, and it travels all the way up. Again, as you can see, that is a divergent. So it's getting bigger and bigger as we speak. So technically the Atlantic Ocean is growing and the Pacific Ocean is shrinking. Okay. Volcanic arcs. Japan and the Aleutian Islands in Alaska are the two big famous ones. It's when one oceanic plate subducts underneath another and it pushes up magma and you get all these little volcanic islands. So it's pretty cool. And a lot of the times when this happens, the water is displaced and causes tsunamis. Okay, rock cycle, pretty self-explanatory. You need to know the basic steps and processes that go from one step to another. So just a memorizing thing. Okay, igneous rocks. You need to know that the two types that come from magma and lava. Magma is below ground, lava is on top. Examples are granite and basalt. One cools slower, hence why you have bigger crystals. So that is from your magma, basalt is lava. There we go. All right, sedimentary rocks. The process of lithification. Make sure and you know some examples. Okay, sandstone is a popular one. We have a lot of sandstone in New Jersey. Ironically, the sandstone, all those brownstones in Manhattan, are actually made out of sandstone that was mined out of New Jersey, Bergen County specifically. So that's a little fun little fact. Okay. So examples of that is limestone, shale, and coal. Metamorphic rocks, perfect examples are marble and slate. Marble we use on countertops and for art, and slate is your shingles a lot of times in homes. Okay, ring of fire, real quick. This is where your hot spots are in the Pacific Ocean. For the most part, these are where all of your volcanic eruptions are located, and a lot of earthquakes happen around here too. So it's a cool little ring of fire thing. So make sure you understand all that. And then hot spots. Hawaii is your most famous for hot spots. All right, this is where a lot of your volcanoes are located, and we'll talk more about that in class, but make sure you know this figure and the caption. All right, and that is it. Oops, one last thing. Landslides and massed wasting.